Hello, and thank you for coming to this virtual presentation. I'm Álvaro Feal, and I'm here to present this paper called Angular Devil, a privacy study of mobile parental control apps, done in collaboration with colleagues from India Networks Institute, Universidad Carlos III de Madrid, India Software Institute, Universidad Politécnica de Madrid, ICSI at Berkeley, and the Spring Lab at APFL. First, I would like to start by giving a brief explanation of what parental control apps are and how they are used. Nowadays, children have access to mobile phones, and with them, they might use applications that are not suitable for children, such as gambling apps. They might use functionalities that might be dangerous for them, such as calling unknown people, or they might access web content that parents might deem inappropriate for kids, such as gun violence or pornography. To avoid that, parents turn to parental control applications, and there are two types. Restriction applications are often installed either on the parent device for when the child is using it or on the own phone of the child, and they disallow children to access functionality such as applications that might be dangerous for them if parents believe so. So when the child tries to access an application that is restricted, it would only see a banner saying that the application cannot be accessed. The other type are monitoring applications. These applications not only block content on the device, but they also collect information about the usage of the phone by the child. These applications are installed on the children device, and then the reports can be accessed either in this device, on the parent device using what is called a companion app, or on websites that are made available by developers to be accessed online by parents. Therefore, parental control applications, by their own design, need to access a lot of sensitive resources in order to provide the functionality that they have. But not only that, in the case of monitoring applications, this information will later travel across the internet in order to be accessed by parents in different devices. Therefore, what we do in this paper is we take a look at parental control applications and what are the security and privacy risks for children and parents. Parental control applications are in fact popular. These are two examples taken from applications in our dataset in which we look at their Google Play profile for the number of installs. We can see that one of them has been installed over 1 million times, while the other one has been installed in over 5 million devices. Not only that, but even the European Commission came up with a benchmarking of parental control tools. So this benchmark is meant to help parents decide which parental control solution to use whenever they decide they are looking for one. So to do so, they give a rating to these applications. This rating measures different things. It measures, for instance, how effective it is, meaning how easy is it for kids to bypass the rules that parents set up. Then another thing they look at is how usable it is, meaning whether it's easy to install, configure, and use. They also look at how pricey it is, meaning how much does it cost to get a license. But one thing that they overlook and they don't take into account is how secure these applications are and whether they are respecting privacy of children or not. We believe that whenever parents are taking the decision of using a given parental control application or the other, privacy should be something that they should take into account, since these applications are going to be accessing very sensitive resources from their children, and it is in their best interest to protect such privacy by avoiding applications that are later going to be sharing this private data. Going a bit deeper into the privacy risks of parental control applications, let's imagine this parental control application that, in order to provide the functionality that it has, needs to access sensitive resources. So to do that, it will request a permission during runtime. Then, it is very likely that the parents will actually grant access to this permission to the application, because it will be needed for the functionality of the app, since they are actually highly privileged. Then, the application will have access to whatever sensitive resource is protected by this permission. But in Android, applications often come with different third-party libraries embedded. For instance, here I put two examples: Google Analytics, which is a tracking app, which allows to look at how users are interacting with a given with a given application in the phone, and Kidos, which is an advertisement library that is actually specialized in providing advertisement to children. So the problem with the design of Android supervision model is that any third-party library that comes embedded into an Android application will inherit the same permissions as the host application. This means that in the case of parental control applications, which will often require access to sensitive resource, any third-party library embedded has the potential to also access these very same permissions without the parents knowing whether this sensitive content is going to be accessed only by the application or by the application and a third-party library, which can be a breach of the transparency of these applications. So this is the methodology that we follow to study parental control applications in Android. First, we download applications. To do so, we go to Google Play and we do a free text search using the term parental control apps. So we look at the description of all the applications coming back from the results, and we look at whether they have restriction or monitoring capabilities. If they do so, we add them to our dataset, ending up with 46 applications taken from Google Play. Then we run a static analysis in different releases of these 46 applications. So first, we look at the permissions requested across different releases and how this evolves. We look at the third-party libraries embedded into these applications. And finally, we look at permission escalation. This means that we go at the code and look at when a given permission is used, whether the responsible for this usage is the application, a third-party library, or both of them. Then we do dynamic analysis, and we look at actual behaviors of these applications during runtime, meaning that we look at evidence of personal data dissemination and collection practices, and at whether this sharing happens using security measures, such as encryption or HTTPS. Finally, we do a manual analysis of the privacy policies. So to do that, we read the text of these policies and look at whether developers are transparent when talking about the type of data that this application collects and who and whether if they are sharing this with third parties over the internet. The first thing that we do is look at the permissions that are requested by parental control applications. Here, I highlight some of those that are prevalent across the majority of applications. We see the permissions to access course and file location, the ability to read and write external storage, and the ability to read the phone state, which is the one permission that gives access to unique identifiers. We can see a clear difference with the left-hand side and the right-hand side. On the left, we have monitoring applications, which are those that not only block, but also generate reports about the usage of the phone by the child, whereas on the right-hand side, we have blocking applications. Therefore, we can see that there is indeed a high risk of third-party SDKs leveraging these highly privileged permissions in order to access sensitive content from children. In fact, the next thing that we look at is what are the libraries that are embedded into these applications. And here we focus on those that are potentially accessing sensitive resource due to their behavior. So we include social network libraries such as the Facebook SDK. We include advertisement libraries such as Google Ads because they are likely to collect location data or unique identifiers in order to provide targeted advertisement. And we include analytics libraries such as Firebase because they often collect unique identifiers in order to link the actions of users to unique users and then understand how they interact with these applications. The last thing that we look at statically is permission escalation, meaning that we look at the code and when a given permission is used, we check whether this is used only by the application, by a third-party library, or by both. We find that the access to find location in 55% of the times is needed by both the application and a third-party library, whereas in 9% of the times, only the third-party library is the one responsible for the use of this permission. In the case of read phone state, which gives access to unique identifiers, this is used in 18% of the cases by both the app and a third-party library, whereas in 26% of the cases, only the third-party library needs this permission. Finally, for write external storage, 47% of the times this is used by both the application and a third-party SDK, and in close to half the time, in 41% of the apps, the SDK is the only one using it. This means that indeed, third-party libraries are using and leveraging the kind of sensitive resources that parental control applications have access to in order to collect sensitive data. Not only that, but they are often the ones that need these features in their code and then they are the ones responsible for these applications being overprivileged. So, after we have run a static analysis in order to find a higher bound on the potential privacy risk of parental control applications in Android, we actually run dynamic analysis to find actual behaviors during runtime of these applications. So, for every app, we first install the application into a highly instrumented phone that allows us to collect network traces and highlight what kind of information is being collected and shared by parental control applications. Then, in order to stimulate the application, we create an account, we sign up using what will be the parent email, and then we configure several rules, setting up the phone as if a child below the age of 13 real years of age will be using it. Then, we simulate children behavior, meaning that we interact with the phone and we do several things to try to trigger different behaviors from the parental control application. So we access web page, both those that might be whitelisted, such as um, news domains, or those that might be blacklisted, such as pornography domains. Then we access different type of applications, those that should be allowed, such as children games, and those that are more likely to be blocked, such as dating applications. Then we do use some other features of the phone, such as taking a picture or sending an SMS or pretending to call a phone number. While all of this is happening, we are capturing network flows in order to try to find what are the data collection practices of these applications and whether this data that is collected is then shared over the internet using appropriate measures of security to third parties. It is important to say that in this test, we are actually accepting and granting consent for the data collection and sharing practices of the application and third parties. As you can see in this screenshot, regardless of the poor choice of color by the developers, when you actually create an account and sign up with the applications, you are granting access to collect to the collection. But still, we find interesting cases. For instance, the location is being shared with different third parties in these applications. Well, in the case of COPA, which is the Children Online Privacy and Protection Act, in the case of children below the age of 13, location is a piece of highly sensitive data that should not be sent and shared with third parties. Furthermore, we find that close to 0.5% of the time, when a resettable identifier is sent in a network flow, they are also sharing a non-resettable identifier. The whole purpose of having resettable identifiers is that users can reset them and then all previous actions from this account will be unlinked from their current persona. Nevertheless, sharing non-resettable identifiers as well completely bypasses any of the privacy benefits of using resettable identifiers in the first place. Furthermore, this is a potential violation of Google's terms of services. But we also run a different test in which we do not consent to any data collection. This means that we only install the application and then we never sign up for the parental control app and we don't send any kind of swipe or touch to the screen. So we only open the application and collect network flows. Still, we find information such as the Android advertisement ID, which is a resettable identifier, non-resettable identifiers such as the IMEI, location information, and email information being sent out without appropriate parental consent. This is a potential violation of both GDPR and the COPPA rule. Furthermore, in current privacy regulation in both COPPA and the GDPR, they state that when applications are collecting information from children, and if they are later going to share it, they should use reasonable measures of security. We believe that reasonable measures of security should be, at the very least, using basic forms of encryption, such as HTTPS. Nevertheless, actually, in both of the tests that we ran, we found that there are applications that not only collect and share data with third parties or first parties, but they do it without using basic encryption, meaning that any eavesdropper that is in the network could actually get access to personal data from children. So the last thing that we do is a manual analysis of the privacy policies. So we read the text that developers put in their legal documents and compare this with the behavior that we found during the dynamic analysis. we found that only 24% of the applications clearly state which data they collect, and only 28% of them name all the third-party services that we found during dynamic analysis. So this means that there is a lack of transparency in these documents. Then, because we actually started our project before GDPR, we took snapshots of those of privacy policies for companies that we had from before GDPR and after May 25th, 2018. And we found that only 2 companies included major changes in their policy after the GDPR. So the conclusions of this paper are that parental control applications in Android are dangerous for children's privacy because they include dangerous third-party libraries, which often ends up translating into private data dissemination happening in these applications, both when parents are consenting to these data collection and sharing practices and when they are not. Furthermore, we find that this private data dissemination often happens without using basic means of encryption, putting the privacy of children at further risk. Finally, there is a lack of transparency in parental control applications because when looking at privacy policies, we find that developers very rarely talk about what kind of data is being shared and which third parties are receiving this information. To finalize, we want to give some recommendations to both parents and developers. In the case of developers, they should avoid using third-party libraries whenever they are making applications that target children, especially in the case of parental control applications, as we have shown that they access really sensitive data. When this is not possible, they should rely on SDKs that are suitable for children. For instance, Google has come up with a list of third-party libraries that have been self-certified as complying with current children legislation. We believe that this shows better faith than including third-party libraries that clearly say in their terms of services that they are not meant to be used in applications that target children. In the case of parents, they should favor restriction apps over monitoring apps. We have shown that because of the kind of features that they have, monitoring apps collect more data than restriction apps, and they access more sensitive resources. Therefore, the potential for third parties piggybacking off these permissions to collect data is much higher in monitoring applications. But finally, we believe that it will be even better if parents rely on non-technical parental control solutions to avoid the possibility of data from their children being collected and shared with third parties over the internet. With that, I would like to conclude this presentation, point you to the paper if you want more details, and open the floor for questions. Thank you very much for your attention.